I'm telling you.
Okay. We're going to do the decomposition of hydrogen peroxide. You might have a bottle of this at home. All right, so sometimes maybe you put it on your cuts at home, but that's actually 3% hydrogen peroxide. This is 30%. It's much more potent and it burns your skin instantly on contact. So that's why we're using gloves. So one of you, I'm just going to give you the things that need to go over. Nick, we're going to actually do this reaction in a graduated cylinder. Can you put that, Nick, on the center of the table?
Do you guys care if you're on camera at all or no? I'll keep you off there. I'm gonna keep you guys off.
All right, so what we need is the hydrogen peroxide, which basically we're doing the decomposition of hydrogen peroxide. We're gonna need soap because it's gonna produce a gas, so go put that next to there. And also the important thing for this reaction is that we're gonna use a catalyst. This is potassium iodide. And a catalyst is basically just a substance or a chemical that we're gonna add to speed up the process. It doesn't actually partake in the reaction, it just speeds it along. You have natural enzymes or enzymes in your body, which are catalysts within your body that speed processes along. You probably learned that in biology last year. Potassium iodide is just a chemical catalyst. And basically you would see this listed on top of the arrow in a chemical reaction if there's a catalyst necessary for a reaction to occur. So, Joe, why don't you open up the peroxide carefully, and we're gonna pour about 50 milliliters into the graduated cylinder. We'll get it to be a little bit closer. The two products of this reaction, one of the products is oxygen. So it's a gas, go ahead and pour it. And so in order to help capture that gas, we're gonna use soap. So I'm gonna have Joe put in the hydrogen peroxide, and Nick, you're gonna put in the soap right after. About 50 milliliters. Doesn't have to be perfect. Nick is gonna add in the soap, cap it. Give that right back to me. Keep your gloves on because we're not done yet. So add a bunch of soap, just tell him when to stop. Joe, add a couple drops of dye. To make this a little more exciting, Joe is gonna add food dye. So the soap is there so it captures the oxygen gas. You can put that one here because I use it here. That's good. I'm just gonna mix it up a little bit. And then Nick, I'm gonna have you add the catalyst in a moment. But I'm gonna put a tray to help kind of capture this. All right. This is sometimes called elephant's toothpaste. I don't know if you've ever seen this demo before, but it's called elephant's toothpaste. And the reason is because when it does shoot out, it kind of looks like toothpaste coming out of a...
And they used to do it, they do like the food color like on the side of the glass, so they do like a red and a blue streak, so that when it comes out, it looks like toothpaste for it.
That's even cooler.
I'm not that artistic though.
Oh yeah, I'm not that talented. So Nick, all you're gonna do is add the catalyst, and we're gonna step back and watch this. And then I'm gonna perform the glowing splint test on it as well after. So Joe, you can help me with that.
All of it?
All of it in, and then step back.
Oh shoot.
So it kind of looks like toothpaste, I guess, coming out of its container. So basically the soap was added so that we'd actually get that visual effect. Can you guys see the steam coming off of it too? It's an exothermic reaction. You can put your hands in there, you can feel it. It's not that hot.
Oh yeah, I feel it. It's perfect. Like, you didn't even get any off the hair.
All right, so now we're gonna perform the glowing splint test, which basically tests for the presence of oxygen. So I'm gonna light up a splint.
Maybe you can't blow the match out with the mask on.
I know. I'm gonna cheat a little bit. I can't blow it out. All right, Joe, I want you to put that into the flame and then pull it right back out because it'll relight.
Yeah.
Go ahead, hurry up quickly. Oh, well, we didn't do a good job. But
Try it again.
probably my fault.
Slowly.
Give it to me.
Yeah.
I will try to do the other side.
Yeah, just when you put it in, go slowly, because if you go too fast, you're gonna put the flame out anyway.
Alright, yeah.
There.
Slow down.
It wasn't enough. Sorry, guys.
Welcome to science,
Total
children.
fail. The mask doesn't help because it's like harder to get the mask off to blow it out. But I guess that's what we're dealing with.
Changing color, it's drying up.
You want the ember so that it relights. So go ahead.
There you go.
Try it. Now put it in and dip it in and pull it right out. And then pull it out. See?
I'm gonna
So you can see it relighting. Can you guys kind of see that it like blew up or it lit up a little bit more each time?
Nice on here.
And that's just
Yeah.
proving the presence of oxygen because you need oxygen to sustain a flame. So that's called the glowing splint test. So clearly there's oxygen present in it. Still coming out, still going. And that's it.